Google scientists claim another quantum advantage by completing a computing assignment on a quantum computer that would take a traditional supercomputer 47 years to complete. However, scientists in China have just completed a similar computation in a few hours using standard processors. They claim that their supercomputer could completely defeat Google's Sycamore. So, what's the case? Which computer is more powerful? Or more importantly, are these quantum computers really groundbreaking as the claims suggest? Is Google truly ahead of the competition? Hang around and we'll try to answer each and every question. Hello and welcome back to Quantumfy. In today's video, we'll see Google's quantum computer reaching unprecedented heights. So let's get started. More is sometimes better when it comes to reducing error rates in quantum computers. That is, more qubits. The quantum bits, or qubits, that comprise a quantum computer are prone to errors that, if not addressed, can render a calculation meaningless. Scientists hope to construct a computer that can rectify its own flaws in order to lower the error rate. A machine like this would merge the abilities of numerous flawed qubits into one better qubit known as a logical qubit that can be utilized to perform calculations. Scientists have recently achieved a significant milestone in quantum mistake correction. The number of qubits in a logical qubit can be increased to make it less error-prone. Future quantum computers could one day be able to solve issues that even the most powerful regular computers cannot. Researchers agree that in order to develop these massive quantum machines, they'll need to apply error correction to drastically reduce error rates. While scientists have previously proved that small-scale quantum computers can detect and rectify basic faults, error correction is still in its early stages. The recent breakthrough does not mean that researchers are ready to develop a fully error-corrected quantum computer, but it does show that it certainly is conceivable and that error correction fundamentality works. Logical qubits hold information in several physical qubits in a redundant manner. This redundancy enables a quantum computer to detect and correct errors as they occur. Ideally, the smaller the error rate, the larger the logical qubits. However, if the initial qubits are too defective, adding more of them will cause more issues than it will fix. The researchers investigated two distinct sizes of logical qubits, one with 17 qubits and the other with 49 qubits, using Google's Sycamore quantum processor. The researchers calculated the faults that still snuck through after steadily improving the performance of the device's original physical qubits. The larger logical qubit had a lower error rate, around 2.9% per round of error correction, than the smaller logical qubit, which had a rate of approximately 3.0%. That minor improvement shows that scientists are finally approaching the point where mistake correction can begin to squelch errors by scaling up. However, the findings are only on the verge of showing that error correction improves as scientists scale up. A computer simulation of the quantum computer's performance implies that increasing the logical qubit size might actually increase the mistake rate. Additional improvements to the initial defective qubits will be required before scientists can fully reap the benefits of mistake correction. This was only a year ago, but fast forward to today, it seems like the dawn has finally passed out and the sun has come out with rays of bright hope. Google researchers published their findings on the prepress server archive. Before seeking official peer review, scientists frequently use the archive server to share findings. The researchers took advantage of the most recent version of Google's quantum computer, a 53-qubit machine called Sycamore, which was used in one of the first attacks on the Quantum Supremacy milestone in 2019. Quantum Supremacy is the theorized moment at which a quantum computer can complete a task that is much beyond the capability of the traditional computer or supercomputer. The scientists employed an updated version of Sycamore with 70 qubits for this purpose. A qubit is the fundamental unit of quantum information, similar to how a bit is the fundamental component of classical information. With these extra qubits, the new processor is 241 million times more powerful than the previous one. However, other factors, such as a coherence duration, can affect quantum computer performance. The experiment is intended to resolve problems about classical versus quantum debates. The scientists carried out a random circuit sampling task in the experiment. In quantum computing, this entails evaluating a quantum computer's capabilities and efficiency in tackling difficult problems by running random circuits and examining the resulting outputs. The experiment has received positive feedback from the research community, while questions about its feasibility remain. One of the major complaints leveled at previous quantum advantage studies is the feasibility of quantum computing jobs. For example, most people may not require boson sampling or random circuit sampling right away, but they do require access to practicality and functionality of the speed and power of these quantum computers. The researchers also claim that this outperforms a recent demonstration from Chinese laboratories. These Chinese research teams were among the latest to announce quantum supremacy, but in the end, the aim is that these more esoteric researchers will result in technology and functionality that will provide the groundwork for more realistic computations and use cases. So this was it for today, guys. Hope you enjoyed our video. If you did, then like and share the video and subscribe to get quantified. Stay tuned as we'll be back soon with another important video. Till then, keep watching Quantumfy.